record? Okay, perfect, it's recording. Nice. So force of interest and MPV. Okay, so let's do this one first. So you have the force of interest of a two variable financial law that is constant and that is equal to 0.05. What is the future value of a principal C invested from X2 to Y4? So I mean, seeing as you guys are very few, if you want, I can even like just give you 2 minutes to do it, and then I'll show you the answer later. Do you guys prefer that, or do you want to just see the solution right away? Just let me know how you prefer doing it. Okay, yeah, you can try it first for sure. I'll give you 2 minutes to do it. There you go. When you're done, you can also just put your answer in the chat. So you think it's A? Okay, it's only been 1 minute. I can wait an extra minute and then we'll see. I really feel like the teachers like in class that's like, I'll give you guys 4 minutes. Also about these type of questions, like I remember last year sometimes they will really ask something like this, and like you would do, you know, an entire like formula, an entire computation and stuff. Like you finally had the result and you saw there was literally none of the preceding, none of the above. And you're like, I did all this for this, just like not even to see the answer in the available ones. It's very frustrating. But like sometimes it can happen that it's actually none of the above. You're kind of the teacher. Gracias. Who do you guys have as a teacher? Oh, so you said A as well? Okay, so now I guess we can see. It is A indeed. Congrats. So basically, how do we know that it's A? Because here they give you a hint. They tell you that the force of interest is constant. So what does it mean? It means that it is a compound interest. You know it's going to be compound interest. And thus you're searching for ft equal to exponential of force of interest times t. And thus if you plug it in, you can find c times ft. Do you guys have any questions about this one? Yeah. Great, great, great. Then, support. You said that duration, you guys were good. Oh, this one also about force of interest. So you have a financial law with the force of interest equal a plus bx plus cy. The financial law will be decomposable if and only if. Tell me. This, you literally have 30 seconds for this one, guys. It's like so easy. A very famous theorem that you should know by heart. C? No, it's not C. Just like, oh, I didn't see the last message. D then? No. I'll just give you guys the answer. Why sometimes it is not, like, I cannot switch slides sometimes, it's so weird. There you go. It's E, because basically you have to use Contides theorem that is saying that it is, you have decomposability if and only if the force of interest does not depend on X. So here, not depend on X, you just need B to be equal to 0. That's all you need. Do you guys remember this theorem?
Now I do.
Okay. No, don't worry. Okay. Then what else do we have? MPVs, okay, do you guys want to do maybe this one? This one is a more like theoretical question. So you have a financial operation with an internal rate of return of 5%. Which of the following statement is true? So basically, if it's a loan, how, like, does the opportunity cost of capital have to be lower or higher than 5%? And the MPV, will it be lower or higher than 0? And same if it's an investment. So basically you have like all the all the possibilities and you have to choose the one that is correct. Actually, being a teacher is harder than we think, like in terms of technology. Like always, like sharing the screen with the slides and stuff, recording. Actually, we always make fun of teachers, but it's not that easy. Or maybe it's just me who's a boomer as well. Could be possible. Oops, yeah, I think I literally just showed you guys the answer. Lol. But it's so weird, I cannot even see the chat. Is it gonna work like this? Okay, there you go. What was this one? Do you guys think you have the answer? What do you guys think it is? Maybe A? Okay, so I guess I'll just show you guys. There you go. It's actually C. So why is it C? You have to remember those, I mean, it's not really theorems, but like those properties, I guess you can call them, is that if you have an investment, in order for the investment to be beneficial, to be profitable, and for you to end up like doing this investment, you need, I mean, obviously the MPV to be positive, and that is the case for both investments and loans. So that's why A cannot be possible, because here it says we'll have an MPV that is negative. So you want the MPV to be positive, and then it's gonna actually change for the internal rate of return with respect to the cost of capital. If you have an investment, you want the internal rate of return of the investment to be greater than the cost of capital. But for loans, it's actually the opposite. You want the internal rate of return to be lower than the cost, than the opportunity cost of capital. Because for the investment to be interesting, you want the return to be higher than what it usually is on your other projects. And for the loans, it's the opposite. You want it to be actually lower. So then if you go back to the different possibilities here, so you were saying A is not possible because it says if it's a loan, an individual opportunity cost of capital, an individual opportunity cost greater than 5 will have an MPV negative, and therefore you will not take it. If it has an opportunity cost that is higher than 5, wait, if it's a loan, opportunity cost, actually, wait a second. Then see, it's if it's a loan, an individual opportunity cost that is greater than 5 will have an MPV that is greater than 0, and therefore you will take it. But for a loan, if the MPV is greater than 0, it means that yes, exactly. That the opportunity cost of capital is higher than 5%. Because here in the instructions, what they give you is the internal rate of return. So basically, if you have a cost of capital, as C saying, that is greater than the internal rate of return of that loan, then you will want to have it. You will want to take it. So you're going to have a positive MPV. It's true that it's actually kind of confusing, all those signs. So yes, just be careful, like the rate that they actually give you. Here is the internal rate that they give you, and then they give you the opportunity cost of capital in the different possibilities. So here, internal rate of return that is equal to 5%. In order for you to be willing to take the loan, and thus the MPV of the loan to be positive, you want the opportunity cost of capital to be higher than this 5%. Because basically it would mean that this loan with an internal rate of 5% is quote unquote cheaper than your usual project, your usual loan, and therefore you will want to take it. If it makes sense. Does it make sense? Like just remember those relations. Like for investments, you want MPV positive, I mean MPV positive in both cases, but you want IRR to be greater than I, and for loans you want it to be lower. Does it make sense? Yes, great. Then let's see what else we could do. Oh yeah, this one is actually kind of interesting. So you have a loan I mean, you have several loans and they ask you which one is the most convenient. I mean, this question, like I found it pretty interesting because, you know, when you're in an exam, you might be like, okay, let me compute like all the rates of return of like all those loans and I'll see which one is the most convenient and which one is the cheapest for me. But there's actually an easier way to do it. So I just wanted you guys to see if you saw this easier way to do it. Because sometimes, you know, in exams, you should also like just read the question and not necessarily rush and just think about some shortcuts, you know, that will make you like, that will logically give you the answer pretty much right away. Like here, you guys should see, my God, you guys can see the answer on the left right now. Like here, you guys should be able to like know the answer right away. Can you see it? Do you guys see the shortcut here? You might be like, oh my God, what is this girl talking about? She's crazy.
No, actually, where is it, Margot? Because I cannot see that.
Okay, so basically here, the answer, like you could see pretty much right away that it's A, because in any case, if you compute, you see that, I mean, the loan, you're gonna receive 100, and then in any case, you're gonna basically cash out 120 in any case. But in the first case, it's 120 that you're gonna cash out in 2 years. And in other cases, it's like spread out like between year 1 and year 2. But in other cases, you see that if you sum it, it's 120 anyway. It's gonna be like 120, it's gonna be 100 and then 20, it's gonna be 90 and then 30, 30 and then 90, 60 and then 60. And so basically, like right away, you can just think, well, hold up, the most convenient for me is just, you know, to pay as far in time as possible. Like you'd rather just pay directly 120 in 2 years, because those 120 in 2 years, then you know that whatever the interest rate is, if you're going to discount it to the present, it's going to be cheaper anyway, because you're going to discount it more than if you had also made an intermediate payment at year 1. If it makes sense, you'd rather pay it as late as possible. So that's why the most convenient, you can just see that it's A here right away. What else do we have? This one is a bit computational. It's like it's just an annuity due. So it's to see if you guys remember the formula for annuity dues. Here you have an annuity due that is that has 13 annual installments, each of 900, and they ask you the present value of the annuity if you have a compound annual interest rate that is 9%. So here you just remember and plug in the formula. I mean, it's already 7:07, so maybe I'm just gonna quickly like go through it with you guys. So here, yeah, you just remember the formula of an annuity due. So it's going to be R times 1 minus 1 plus I to the power minus n divided by I times 1 plus I. And so here you plug in everything. They give you everything. So R here is the installment. So 900. Then you multiply by 1 minus 1 plus I, that here was 9%, to the power minus 13, divided by 0.09. And it's equal to C. Answer C. Then this one, okay, yeah, this one was also interesting. Basically, they give you a loan of 68,000, and it's repaid in two installments that are equal to R after 6 months and after 12 months. And what they give you is the nominal annual rate of financing. So they basically just give you J2, 13%. And they want you to calculate R. So basically here, first of all, they only give you J2, so you have to compute the actual period rate, so actual I2. So you take your J2 that you divide by 2, because remember that IK is equal to JK divided by K. And so then you got to be careful that it's this I2 that you're going to plug in your formula, and it's not J2. So here you have your loan. It's basically the initial closure condition. You have your loan, so 68,000, that has to be equal to the first installment, R, that you're searching, and that you discount by 1.065 that you got by dividing J2 by 2, plus the second installment that you're gonna discount by the same rate, but squared. And so then you just have an equation with one unknown, and you find R. So this one we did it. Portfolio, you guys said that you it was fine for you. So yes, just here you have the formula in case you didn't remember the formula for durations. Basically, it's just that you're gonna take all your cash flows that you discount to the present, but you multiply it by T. So for example, here in that case, you had, for A, you had 200 times 1 that you discount, and then at time 3 you had 1089 that you discount and that you multiply by 3. So basically it's this formula, cash flow that you multiply by T and that you discount, and then everything divided by the price. Here in this formula they write it in the more complicated way because they say it's divided by the sum of the cash flows discounted, but this is pretty much the price. So yeah, it's just cash flow times T discounted that you divide by the price. And here they were asking you for the duration of the portfolio. So you computed the duration of A, the duration of B, and you just simply did the average. Here, this question, it was about spot rates. So you consider the following spot rates. You have H0 from 0 to 1, H0 from 0 to 2, and H0 from 0 to 3. And they ask you the forward price, V0 from 1 to 3. Here, I mean, if you guys want, I can give you a couple of minutes to compute this one because it's kind of like a couple of steps in the computation, so it can be interesting for you guys to do it. So if you want, I can give you like a couple of minutes to try to compute it. Just let me know when you guys are done computing this one. Are you guys done? Are you guys still alive as well? Give me signs of life. You're alive, but you gave up for this one. Okay, then let's just show the answer. There you go. The answer was A. So here, what you want at the end of the day is the forward price. Okay, so you know you're gonna use this formula. You know that somehow you're gonna use this formula that links the forward price and the spot rates. But the problem is that in order to have the forward price from 1 to 3, you need H from 1 to 3. And here they only give you H from 0 to 1 and from 0 to 3. And so you got to remember this formula that links H. What did I write? T, it's not H. It's H. That links H from 1 to 1 3 to H03 and H01. So basically you're going to get H13 this way. You just use this formula. So it's 1 plus H03 to the power 3 divided by 1 plus H01 to the power 1. And out of this, you take the square root and you minus 1. I mean, in the actual formula, it's you take power 1 over t minus s. So here, power 1 over 3 minus 1, so 1 over 2. So yeah, it's just plugging in the formula. And then you end up with this. You end up with H from 1 to 3 that is equal to 0.1401. And then when you plug this H13 into the formula for the forward price from 1 to 3, you get your forward price. So yes, basically here it was just 2 steps. First, computing your rate from 1 to 3, using the rates that they gave you from 0 to 1 and from 0 to 3. So remember this formula, H from S to T is equal 1 plus H from 0 to T to the power T, divided by 1 plus H0S, everything to the power 1 divided by T minus S. And I mean, everything minus 1 together, right? And yes, that was pretty much it. It's true that it's like kind of a complicated formula, so you got to use it a couple of times to like remember it well, because it's kind of tricky. I mean, honestly, there's not necessarily logic behind this formula. It's unfortunately, you know, that type of formula that you just gotta learn and accept and like, you know, take it as it is. So yeah. This one we already did it. Famous Canteri theorem. This one we also did it. This one we also did it. We can do this one because I just wanted to show you guys like oh, there's people entering. Wow. Because I just wanted to show you guys a matching question, like what it could look like. So here they give you an investment where you cash out 100 euros and then you're going to receive 121 at T2. And they also give you a loan. So this loan, you're going to receive 60 bucks at T0, and then you're going to have to pay 2 equal installments at T1 and T2. They give you the financing rate 5%, and they give you the opportunity costs from period 0 to 1 and period 0 to 2. And here there's a couple of things that you got to compute. There was actually a mistake in the paper, so that's why you can see that here the last 2 are crossed out, because I'll explain to you guys why here it's not like possible to compute them. But let's just do it like, you know, in the order. So first they ask you the residual debt, D1, and then they ask you the outstanding capital, and then the Jpv. So let's do all this. What is the first thing that you got to do? It's to find the installments R. Why do you want to find the installments R? Because you want to compute the net flows. So basically the net flows that are going to happen every year. so first of all, compute R. This we've already done it in one of the exercises. Use the initial closure condition. So you want the 60 euros of your loan to be equal to the first installment that you discount, and the second installment they're going to discount twice using the rates that they gave you. This is, wait, let me just slideshow from current slide. Okay. There you go. So using the initial closure condition, you can figure out R, and here by doing so, you find that R is 32.27. Here, what you're going to do after that is compute the net flows. So at T1, what happens? At T1, you're going to have minus 10 plus 60. So you're going to have a total like net flow of minus 40 euros. Then at T2, at T1, here instead of doing 0, 1, 2, I did 1, 2, 3. Okay, let me just change it because otherwise it's going to be confusing. Here, sorry guys, I meant 0, 1, and 2. So at T1, what is going to happen? You have nothing, you have no flow in your investment, but in your loan, you have minus R that you just computed, so minus 32.27. And then at T2, for your investment, you have an inflow of 121 and you have a net flow of R that you had also computed previously. So you're going to have a net flow of 88.73. Okay, so now you have everything, you have your R, you have your net flows. You can now compute the residual debt. So for your residual debt, what is going to be, you should start at 0, usually it's easier. So your residual debt at D0, it's simply going to be 60, so the entire value of the debt, because you haven't paid back anything yet. And then at D1, what is it going to be? It's simply going to be D0, so 60, that you multiply by 1.05 because you bring it forward of a year. And then, of course, you have to subtract the 32 that you're going to pay back. And so doing this, you're going to end up with a residual debt at D1 of 30.73. So yes, remember how to compute your residual debts. D0 is always, the entire value of the loan. And then from D1 on, you just do dk equals d k minus 1 that you bring forward of a year. And then you subtract the installment that you've made at T. The outstanding capital. The outstanding capital, it's pretty much the same logic. What is your outstanding capital at 0? It's simply going to be 100, the entire value of your capital. And then what is going to be your outstanding capital at 1? So W1 is going to be 100 times the internal rate of return of the investment. So be careful that here you're not going to use the 5% of your finance rates. This one you use it for the loan. To compute your outstanding capital, you need to use the IRR of the investment. So here you're like, oopsie, I have to compute the IRR of the investment. But you know how to do so. You want 100 to be equal to 121 that you discount twice. And doing so, you manage to compute your IRR. Okay, so great. Now you have your IRR. And you simply take your outstanding capital at 0 and you bring it forward of a year. And so your outstanding capital at 1, what is it going to be? It's going to be 110. Great. So for the 2 questions, that was pretty easy. You have J and G. Now question 3, you want to compute the Jpv. You know that the Jpv is pretty much, it's a special type of NPV that is going to take into consideration net cash flows and also floating interest rates, like non-constant interest rates. How do you compute your Jpv? you take your net flows at 0. What is your net flow? It's simply going to be minus 40. Then at 1, you're going to have minus 32.27, but that's your discount of 1.06, because 1.066%, it is the opportunity cost from year 0 to year 1. And then at T2, you're gonna take your net flow of T2, 88.73, and this time you divide it, I mean, you discount it twice by, you got to be careful, this time it's the opportunity cost from year 0 to year 2. So basically in this exercise, the most difficult part is like, be sure that you always pick the right rate. Don't be confused between the financing rates, the opportunity costs from 0 to 1, from 0 to 2, the internal rate of return of the investment. Be careful that you use the right rate. So those were the 3 questions that you could actually answer. The 2 last questions, why can you not answer? Because there was simply a mistake in the paper. Basically, to compute the period equity quota and the period debt quota, you need the opportunity costs from 0 to 1 and from 1 to 2. And here they give you 0 to 1, 0 to 2. So technically, yes, you could compute the opportunity cost from 1 to 2 and then go on with your computation of the period quotas. However, in the paper, they didn't take this into consideration. So like the results that they propose are just, they're not correct. So that's why it was just crossed out. Does this exercise make sense, guys? I think that was honestly one of the things I hated the most in math 2 was like Jpvs. I don't know why. It took me a little while to understand them. Yes, Alice. It is the mock that that Alice wrote, and she has an explanation on her YouTube channel about it. You got it? Okay, great. It's already 29. So this one, we've already done it. This one, duration, you guys said that it was okay. Okay, so this one is the only thing left. I mean, it's really easy. It's just, I'll just show you guys this formula and then I'll let you go. Here you have an investment with a price of 1,000, a duration of 2, and an internal rate of return of 5%. And you want to compute the approximate change in X that will result in a 1% decrease in the price. So here you got to remember the famous formula that is going to follow you everywhere. Even in second year, you have to use this formula in every single subject. The formula that links the duration and the changes in prices. What is this formula? It's simply this. It's delta P divided by P equals minus D that you multiply by the change in the interest rate divided by 1 plus the interest rate. Here you already have the percentage decrease in price. So that's why the percentage decrease in price here, the 1%, I mean the minus 1%, it's already like equivalent to delta P divided by P. But sometimes they might like give you delta P and P separately. So you got to be careful which one you plug in. And yes, equals minus 2, the duration that they give you, times the delta of the interest rate that you want to find, and that you discount by 1.05. And here you find your delta X. Does everything make sense, guys? Do you guys have any questions? It's 31, so I guess I'm gonna, if you guys don't have any question, I'm gonna let you go. If you have any question, you can also stay. write to me. You can find me Margot Rimbert. I'm on Instagram, on WhatsApp. You can find me and ask me any questions. But yes, best of luck for your exam. I'm sure I'm gonna stop sharing if you guys have any questions. I hope you guys are gonna do well. Thank you, Martina. I hope you guys are gonna do well. I wish you the best of luck. It's true that math exams at Bocconi are always something pretty stressful, but don't worry, we've all survived, so you guys can also make it. Just be careful to always read the questions super, super, super carefully, because Bocconi also likes to trick you on, like, you know, theory questions. So be careful. Read everything super carefully. As I told you also, for example, like the type of questions where they're like, you know, there's not the correct answer in any of the answers, and it's like none of the above. That's always pretty stressful when like you've really done like a huge computation and your answer is not even in the ones they propose. So that's pretty stressful, but it can happen. So just, you know, if you do a computation, believe in it, you know. Anytime, guys. Thank you for joining. If you have any questions, let me know. I guess I'll just stop the recording.
Thank you for everything. Goodbye.
Thank you for joining, guys. Have a good evening.